So remember, you can only change the numbers in front. When you have done, like I've done with the first one here, when you do that, the greatest common factor for your coefficients or the numbers in front shall be 1. All right, and again, if we don't put a coefficient in the blank, it's understood to be 1. Now, some of you are probably going to put 1s there just to help you, to give you a little more, make you more comfortable with it. So if you put a 1 in front, it's okay, it's not wrong. It's just you don't have to, because it's one of those agreed things like in algebra class. All right, now remember, this is your reaction arrow, and you have to have an equal number of each element on either side of the reaction arrow. All right, so it's just a simple number puzzle is all it is. So we'll go to the second one here. So we have sodium, we have fluorine, and we have bromine. Those are our elements. So looking on the left-hand side, I have 1 sodium, and on the right-hand side, I have 1 sodium. On the left-hand side, I have 1 fluorine, and on the right-hand side, I have 2 fluorines. On the left-hand side, I have 2 bromines, and on the right-hand side, I have 1. So I'm going to leave the sodiums alone since they're balanced and go to the fluorines since they're the first one that is unbalanced. So the way we balance it is to put a 2 in front of the sodium fluoride here. Okay, so that's great. We now have 2 fluorines on both sides, but now I have 2 sodiums on the left and only 1 on the right. So I'm like, okay, well, no problem. I'll just put a 2 here. See how that works. So now I have 2 sodiums on the right, and now I have 2 bromines on the right, which is serendipitous because I needed 2 bromines on the right. So now when we look at it, we have 2 sodiums on either side, we have 2 fluorines on either side, and we have 2 bromines on either side of the reaction arrow here. The coefficients are 2, 1, 2, 1. So my greatest common factor is 1. So I've met all the requirements for a balanced chemical equation. Now, does anyone need me to review the counting of atoms yet? You know, the coefficient times subscript. We doing okay on that? Because we haven't done that in quite a while. All right. Not hearing anything from you, I'm going to take that as a yes, we're fine. Of course, I know sometimes it means, okay, we have no clue. We don't even know where to start with that, tell you. And being online makes it a little difficult. Let's go where I have, okay, I'm going to go to 12 here because I've got parentheses. Actually, let me back up here. Let's see. I'm going to find one with polyatomic ions. I don't like that one. Yeah, that one's okay. You know what? I'll just go to this one. All right, so NO3 is nitrate. It's a polyatomic ion. And you'll notice, I'll go through here, you'll notice a lot of times the polyatomic ions go through these chemical reactions unchanged. Like here's sulfate, it's a polyatomic ion. It went through unchanged, it just switched partners. It switched partners from hydrogen to magnesium. Come on, computer. And here, nitrate just changed partners from silver to copper. And then the next one here, carbonate, it goes through unchanged. It just switched partners from lithium to magnesium. And then in this one, problem 9, the phosphate went through unchanged. And the hydroxide, this OH, went through unchanged. So you got to watch. Sometimes, a lot of times, hydroxide will be converted into water. So just keep an eye on that. But most of the time, the polyatomic ions go through unchanged. Like on this one, you got CN is cyanide, and it goes, and see here you got sulfate, and they just switch partners. So, so just, it makes it easier to count atoms if you treat the polyatomic ions like they're one thing. Did the way I express that to you make sense? Talk to me.
Yes, making sense.
Okay. All right, so we'll go back to problem 6 here. All right, so we have magnesium. Oh, it helps if I get my pen instead of eraser. Oh my gosh, come on, computer, be nice to me today. All right, so we have magnesium and we have hydrogen. And then I'm going to treat the sulfate like it's one thing because it goes through unchanged. Okay. Now, if that's bugging you, you can switch that out to sulfur and oxygens. What I'm doing, it just saves time. That's all. It makes it a little faster. All right. So let's count left and right. We have 1 magnesium. We have 2 hydrogens on the left. We have 2 on the right. And we have 1 sulfate on the left and 1 on the right. So do I need to do anything? It's a trick question. I don't need to do anything because, look, what are my coefficients? They're all 1. So the GCF is 1. I've got an equal number. I've got the same number of each substance on either side of the reaction arrow. So it's already balanced. So watch that. That's one of the that's actually the only trick problem you'll get in balancing equations is the problem where you don't need to do anything. That was me opening my yogurt. I'm getting a little hungry. So, all right, questions so far? All right. Oh, was that a no question?
Yeah.
Okay. So we'll go, I'm going to go ahead and go here to number 9. Okay, I've got sodium phosphate and potassium hydroxide yields sodium hydroxide and potassium phosphate. All right, so counting on the left, I have 3 sodiums on the left and I have 1 on the right. I have 1 phosphate on the left and 1 phosphate on the right. I have 1 hydroxide on the left and 1 on the right. And I have 1 potassium on the left and 3 on the right. This is a pretty easy one. If you break these down, that's not what I wanted to say. If you keep these as polyatomic ions instead of separate atoms or elements, it makes it a lot easier. All right. So just simply go through, start with the first one. Okay, so we put a 3 here. So this is 3 now. Now my hydroxides are 3. But that's not a real big deal because I need to go over here and put a 3. You see, because I got 3 potassiums on the right, 1 on the left. So if I put a 3 there, I have 3 on the left. And I've got 3 hydroxides on the left. So now I got 3, 3, 1, 1, 3, 3, 3, 3. Those are wonderful check marks, huh? Yeah, look like a first grader did them. Oh well. All right, so this one is now balanced because we got 1, 3, 3, 1. GCF is 1. Again, I only changed the coefficients, and the GCF of the coefficients is 1, and I've got an equal number of the substances on either side of my reaction arrow. All right. Do you need more? Or are you ready to proceed on your own?
Proceed on your own.
All right, so I'm going to stop recording and presenting. And this is all we'll do. We'll just do some of this. This is all we'll do between now and, so we got 4 classes. We got 3 this week and 1 next week. And so the way I'm looking at it, it should be an easy way for you to protect your grades. And if you need to come up a little, it's a way to help you improve your grade. So it's the way I'm seeing it, because generally with practice, most students get this and kick butt at it. But, you know, I do know it goes back to that thing I keep talking about on brain wiring. There are some students that no matter how hard they try, this is still a mystery to them. If I could figure out why, I could probably make a lot of money teaching it, because, you know, it's like, but for some, it's kind of like, again, I liken it into art or playing an instrument. You know, some of us, no matter how hard we try, we're not going to be able to draw a face, you know, that looks good, other than maybe a stick figure, you know, or a smiley face. And even if I tried to draw a smiley face, it'd be, dude, that's pretty bad. But I got other students that, you know, I have students through the years that they can just draw just about anything and do a great job at it. Whereas I could practice forever. It's spelling. I have to constantly work on my spelling. I mean, I got a master's degree in education and I still struggle with spelling. So my point is, you know, from my experience, it has nothing to do with intellect or intelligence when it comes to some of these things. It just has to do with how our brains process things and our aptitudes. However, you know, I think some of this is learnable with practice, but again, you would think after all the years in writing I've done that I'd become proficient at spelling, but I still struggle with it. So it's that's kind of a mystery to me, is why, you know, if you knew how much I've written, my goodness, you know, right now we're actually working on writing a book about some cool experiences I had as a kid, because my grandparents had, you know, a business in a state park, and I'm writing about that. So anyhow, all right, I'm getting carried away here, and this is, I had stopped recording, so this is part of the recording. Anyhow, have you got any questions before I turn you loose?